Hello, I'm James, and I'm recording an updated tutorial on the Volumetric Vesuvius labeling repo. The purpose of the repo is to provide custom tooling and extensions to Napari 3D Viewer so that we can manually annotate volumetric masks of the Vesuvius scroll data. The purpose of doing that is so these labels can be used to train machine learning networks so we can hopefully separate sheets automatically and make inroads towards the automatic segmentation, especially in dense and compressed regions. And I've developed a bevy of features and additions to Napari that will hopefully help with that. So the first step to set it up is to clone the repo, and once you've done that, you have to set up the conda or set up your environment. I provided the commands to do so with conda and pip install with the requirements file. And once you've done that, you'll have the repo, which will look something like this. The first thing you'll have to do is create a data folder, and within that data folder, make an NRD cubes folder. And that's where you'll put all the cubes from the download server. You should have the mask and the volume files like this, and they should be named the same way they are on the download server. I put the link to that page here, so you can get some cubes. Once you have the data in our NRD cubes folder, you should copy the Napari config file and then make a new copy of it and rename it to local napari config.yaml. The reason to do this is if I change the Napari config, like I add a new hotkey or anything like that, you'll get merge conflicts if you change the config file. So if you make the local Napari config file, that's in the git ignore, so you won't get any conflicts. So you can make you can edit your hotkeys and your cubes without that. So once you've copied the Napari config and made the local Napari config file, you can edit the ZYX values to get different cubes. So we'll be loading in this cube. Make sure you put the leading zeros in for now, and then also you can look at all the hotkeys and what they're assigned to. Essentially, this is the function name. I tried to make them as descriptive as possible as to what it does, but we'll go through most of it. And then on the right are the keys it's assigned to, or the key. These are all editable, so if you want to change these around, feel free to, but I'll be going through the tutorial using the default ones I've set up here after messing around with it for a while. You can also leave some blank. I've left some of the less important ones blank as well. So once you have the data and the config set up, then you are pretty much ready to run it, assuming you've also done the environment. So I have my Napari Vesuvius environment ready to go, so you can just run Python Napari volumetric labeling.py, and that'll launch it. You might get some warnings, but that some of the things aren't assigned, but that's all right. Then you should get a folder or a view like this. I've already started working on this cube a little bit, so that's why you can see there's already some labels separated, but when you just first load up a new cube, it'll all be green. When you're starting to work on a new cube, some things I would just suggest is just running connected components immediately to see if anything's already separated. For me, there won't be because I've already done that. As well as you can erode the labels. This will make them all, it'll make it one voxel smaller everywhere. You can do that multiple times. This will just make finding the connections a bit easier, though obviously they won't be exactly where the original masks were, but you can dilate them back up at the end once you've made all the disconnections. So this is just a convenience function. It'll take a little bit. So you originally load up into the 3D view with the data plane. If you hit A and D, that'll move the plane slowly, and Shift A will jump it around. Now the cool thing about this data plane is if you select the data later, I've also put L on it, you can move it on the X, Y, and Z axes with the X, Y, Z key, but you can also use O to go off axes as well, which might be useful for some things. But the real value in this repository on top of Slicer or above Slicer is you can get different cuts of the label and work with the smaller indices here. So once I hit C to get this kind of cut, you can also hit K or Shift V to get cuts that go all the way across, like this. Or you can hit C to get ones that are erase lights width. So if, say you want a larger one, you can change that to like 50, and then you'll get 50 voxels. Or if you want to be really precise, you can make it small and go like this. And the great thing about this view is you aren't going to be erasing the labels behind it or anything like that. Another thing with this view, yeah, you can see how the labels aren't quite aligned because of the erosion we did earlier. Let's put it back up to 30 because that's a bit more useful. All right. One thing with this is you can hit W to hide the data plane. But if you want to just inspect the raw volume, like here, you can see there's some connections. So we can hit Shift W or select the eraser, and then we can just erase some of these connections that we don't want. Oops, if you make a mistake, Command Z works, or Control Z. And to navigate, you can either hold the middle mouse key to pan, the right mouse key to rotate. Though you can also, if you're in move mode, which is this mode, you can use the left mouse key and the shift left mouse to move as well. But I remapped those to the middle mouse and the right mouse so you can have the eraser selected and not be constantly switching between them. So let's see if we can disconnect all of this. Another cool feature is when you have a cut like this, you can hit R, and what that'll do is it'll give you a preview of the connected components for this part, and you can hit R again to hide it. So it looks like this one, so all these are already separate, but these two and these two are still connected. So let's go find where they're connected, somewhere over here. Make sure we got the eraser up, and maybe it's something like this. Boom. These are pretty messy in here. We'll just get those. Oops. Do a bit of, it might be worth making the width a little bit smaller and then cutting it again. If we cut it, okay, there we go. That's a bit easier to see what we're up to. This is pretty messy, so maybe we want to hide the label. We can hide the label with S, and then you can pan it back and forth to see what the raw data is doing. In this particular section, looks like the cuts should be around here, and maybe the mask isn't quite as good as it might be. So we'll just cut it like that. Okay, so that looks like those two are disconnected, so we can hit R to check. Yeah, I got them all. And then these two, or at least on this part. Now, since we'd have the size, we can hit Q or E to move it up, and then see if there's any more connections on here. It looks like there's a couple. Then hit R to check how it is. Okay, those are good. And then this part, just disconnect those, and if we ran connected, if we just had this slice, it looks like we were pretty good. So you can shift the data around and go back up and down like so. Maybe disconnect this part also, something like that. There we are. You can see some of the papyrus gets a little messy. It might be better if I took a oblique cut more this direction, but that's the general idea of using the thick slice to erase the data. Now you might also, that's useful for more dense regions, but you might also want to just work on the full label as well, especially if you can find connections in the full label, then you can go all the way through it quickly. Like I used that to separate the green and the yellow part because they were fairly far apart already, and maybe we can get these two apart in this view as well if we look carefully. Like that's not connected, but kind of move around. But you see there's a bunch of stuff in the way, which is why those cutting with the plane is useful. It looks like they're connected up here. but that's going to be hard to see. So if I use Shift C, I go back to the 2D mode, and Shift C again will come back to this plain cut mode. If I hit V, it'll go to the full label. So we can go Shift C to come here, and then get a cut so we have a bit more context as to what is going on. So let's see if we can get these two pieces apart also. It looks like they're disconnected all through here, but there's one. So where is it? Yeah, we'll erase that. See if we can find anything else. Is that there? I might just bring it a little closer. And okay, we're good. Let's make this back up to 30 and cut here. All right, those are good. We're just trying to disconnect this part. Okay, here we have some, definitely have some connections here. All right, looks like this might be part of it. Maybe label over there as well. All right, bring it forward with E. Looks pretty disconnected there. Here looks good. I mean, I could be checking with R to make sure it actually is good, but it is fairly obvious on these parts. So okay, now it might actually be disconnected. So if we run connected components, we might see these two come apart. No, they did not. We missed something. Right. Let's be a bit more diligent with our search this time. We can also, if the data plane's moving too slow, we can get the Shift AD, moves those around. So these two, those are definitely disconnected. Yeah. Yeah. Might be right in the corner here or something. One thing is sometimes the Q&A overlap a little bit, so it might be good to go through it at a slightly different erase slice width, as well as see if we can find anything. Oh, what's that? Okay, still connected. Okay. What happened there? Oh, we're following this one. Get this one. Okay. Hid the data. Whoops. What have I done? Oh, I zoomed out. That's what it was. If your plane ends up somewhere weird, it can be a bit annoying to get it back, which I seem to have done. There it is. Okay. Whoops! Don't hide that. That's cut again. All right. Seems good. Run this. Huh. It's bizarre. Apparently I'm blind. Oh, maybe it's... We come out here and see. Check the edges. Oh, that part looks dangerous. Oh. Yeah. That would be it, wouldn't it? Yep, there it is. Alright. Erasing this part here. And, oh, to get out. Yeah, okay, that's probably it. Let's just check a bit further down. Make sure there's nothing there. Alright. And unconnect components again. There we go. We've disconnected it. Very good. Sometimes you just need to make sure you find everything. I'll see if the overlapping isn't working quite as I am expecting, because it should have a 10% overlap for each one, so you don't end up digging around like that. But essentially that's how you can label a cube in 3D with this and get the connected components to work. I'll show you the 2D views quickly as well. If you go here, we see the different labels, and you can use the eraser to like erase different parts, and the A and D or the arrow keys to go through the layers. You'll have the edit dim at 3 by default, but you can change that. But essentially it means when you erase on one layer, it'll affect the 2 layers below and above it as well. Now the 2D might be good if you really want to see exactly what the data is doing under the label, to disconnect them very precisely or something like this, but it's all going to be a lot slower than the 3D, because you're only erasing like 3 layers at a time instead of 30 or something like that. Also, you lose the 3D context if you're off the plane. So, but it is there. One thing I did implement for the 2D view is, say you're wondering where these two are connected, is you can use the up and down arrow to do a, whoops, that's not what I want, to do a flood fill. So you can say, oh, these are connected, and then you can scrub to see, oh, okay, they connect up here. That's where it is, because finding the connections in 2D can be quite a bit harder than in 3D. So then you can start, I don't know, erasing like this or something. It's not very precise, so I'll undo that. But you can use the flood fill in 2D. Some other things is, oh yeah, the padding context. Say you're unsure if these two should be, if they come together, if they're the same sheet or not, you can hit T or this button, and what that'll do is it'll load 100 voxels from around different sheets, and it looks like these two are actually fairly different sheets, so we'll probably want to disconnect that there. One thing with the toggle padding context is it loads a lot more data, though most of it is masked out, so it is a bit slower when you're in that mode, so I wouldn't recommend staying in there for too long, though it seems like my computer is being extra slow right now. But anyway, yeah, so that can also be pretty useful. And then once you're done with your changes, you can save the labels with either H or by hitting the button. It'll load a little bit, and then it'll give you a confirmation that you saved them. Also here you just have a little helper about some of the hotkeys and what some of the things do. You can also pick different background colors or not. I'll fix that. Apparently I didn't import the color dialog. But anyway, that's most of the features. Hopefully it can help you segment more cubes more accurately and quickly. All right. Bye for now.